Alrighty, this calculus lesson is on integration using the trapezoid rule. It's a fast lesson. It's pretty easy, I think. So, and typically you use the trapezoid rule, well, when they ask you to use the trapezoid rule, or if you can't integrate using the u substitution or the power rule doesn't work. Like, for example, if you had 1 over x dx, and you didn't know about integrating that, and you're doing the power rule, and you add an exponent, divide by the exponent, you get 0 over, you get the power of 0, and you can't divide by 0. So you can integrate this using the trapezoid rule. So recall the integral of a to b of f of x dx. F of x was your height right there. That's how high it goes, and dx is your width right there. So it's equal to the sum of all the f of k's times the delta x, where f of k's is my heights and my width is my delta x right there. Remember, your delta x is your right endpoint minus your left endpoint divided by how many rectangles there were on that. Okay, so that's pretty much what trapezoid rule is we're doing all the rectangles. Recall when we did the rectangles, we had an error factor that was either too small on this one, where all the rectangles were underneath the curve, or if we did the rectangles on top of the curve, then the error factor was a little bit too big. Well, what you can do is you can do the diagonals, you guys. You get a better approximation right here using these diagonals right here. Okay, see how you get a better approximation of the curve right there? So what you can do is do an area of a trapezoid. Remember, the area of a trapezoid is 1/2 the sides that are parallel. So base 1 plus base 2 times the height divided by 2. Here, this would be, this is my parallel side with this parallel side, so it would be 1/2 this height plus this height. Well, the height is f of x sub 0 plus f of x sub 1. Okay, so that's what will go in right here, times the height. Well, these are my parallel sides, these are my bases, so this would be my height right there, the difference between x sub 1 and x sub 2. Alright, so let me show you guys. The area of this trapezoid is, here's base 1 plus base 2 times their height between them, the perpendicular segment between them right here, divided by 2. Okay, the area of the next trapezoid is f of x sub 1. Here's x sub 1, so the height is f of x sub 1 plus f of x sub 2, which is this height right here, times the difference between them, x2 minus x1 divided by 2. Okay, so there's my base 1 plus base 2 times the height divided by 2. Okay, the area of this rectangle gets me that. The area of that rectangle gets me that. Alright, and then check this out, you guys. Notice I have f of x sub 1 repeating right here, and I have f of x sub 2 repeating, and I have f of x sub 3 repeating. F of x sub 0 and f of x sub 4 don't repeat. So what I can do is get the area of all of those and add them all up. And instead of doing this x1 minus x2, minus x0 and x2 minus x1, here it is, the whole difference. F of x sub 4 minus x sub 0 divided by 4 equal rectangles right there. There's the half on all of those, so I just pulled the half out right there. There's my f of x sub 0 right here. Here's my 2 f of x sub 1s, those 2 of them right there, plus 2 of the x sub 2s, plus 2 of the f of x sub 3s, they're all the heights, and then finally my singleton f of x sub 4 right there. And that's basically how the trapezoid rule works, you guys. Okay, so it's you take this endpoint minus this endpoint divided by 2n, and then f of x sub 0 plus twice the next one plus twice the next one plus twice, 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 all the way to the endpoint right there. Okay, so it's basically a single, double, double, plus double, doubles in the middle and singles on the ends right there, and that's my delta x right there. Okay? Alright, let's try one of these, you guys. So let's use the trapezoid rule with n equaling 10 rectangles, that's what that means, to approximate this integral right there, okay? So what we're going to have to do is, okay, here's my formula right there. We're going to go b minus a, so it's going to be 1 minus 0 over 2 times n, 2 times 10 right there. And then plug in x equals 0, and we're doing, this is 1/10 of it right there, because it's always f of, when you're cutting them up from this to here 10 times right here, then it's going to be 1/10, 1/10, 1/10. So I'm just adding a tenth all the time. So it's the function with 0.1, the function with 0.2. Okay, you see where I got the tenth from? Because it's n equals 10, and then so 1 minus 0 over 10 is 0.1. So you add them all up, and you get that as your final answer. Okay, that's what you got to do on all of them. If you're doing a trig one, just make sure that your calculator is set in radians, and it's the same method, you guys. You just do the same thing. All right, and if you're in my calculus class, I would assign that for your homework. Take care.